Okay, so a little bit more with operations with functions. So the first page of this is more review of how we're going to rewrite our functions and our operations with them. So remember, if I give you f plus g, that's telling me that I'm going to add these two functions. The variable you'll see in each one is going to be x. So what I like to do is expand it so I can see each of those functions separately. So this is the same thing as f of x plus g of x. I just find that a little clearer. I don't think I'm going to have to distribute that. Remember, with functions, all we can do is simplify. We can't solve them. We can solve when we have just variables, but functions are rules, and it's telling us what to do. And when we do replace these with the right-hand side of the function, we are probably going to want to use brackets or additional parentheses, that kind of stuff, especially when we do subtraction. So subtraction, f minus g, meaning I'm going to subtract those functions. I have variable x. So this is just going to look like the first step would be f of x minus g of x. And then I would replace with the right side, distribute that negative sign, and all of that stuff. Multiplication, this is just going to be f of x times g of x, using parentheses. Now, be careful with this, this last one. It gets a little confusing just because they give us a little bit more information. This just means we're controlling it so you won't divide by 0. Okay, so the one rule that we have in math right now is that we can't divide by 0 because it just doesn't make sense. And if you were doing things on a calculator and you try to divide by 0, you do get an error on your calculators. It is a divide by 0 error, meaning it's not something that we have a definitive answer for. So we just try to avoid that for the most part. And that is how we say it. So it's saying the function I'm dividing by is never going to equal 0, so I'm not going to have that divided by 0 error. So this is just added notes that we have. When we do the division, we're still going to break it down to f of x. Oop, I should have it in blue. All right, so back to blue. So f of x over g of x. All right, so when we're looking at this, we're just going to be plugging things in, simplifying, and then saying what our simplified answer is, or simplified expression is for our rule of the function. Now, the last little bit, the domain consists of all the x values that are in the domain. So all of the values that we're allowed to plug in for the x's, so anything that we can use in the domains of both f and g. Now, there are some practice problems that you get to do. So you're using f of x equals negative 4x plus 3, g of x is 5x squared plus 7x minus 2, and h of x is 3x minus 1. I will put the answer key up for this, but I would like you to do these yourself, so I'm not going to put those into the video unless people have questions with that, but check your answers, try to do the problems, and see that they make sense. When we're identifying the domains of each function, this we will talk about. Domains is what we're allowed to plug in. So if I'm looking at f of x, basically I'm saying, oh, what am I allowed to plug into that equation that's at the top? The only rule that we have is we cannot divide by 0. So as long as there's no variable in the denominator, we're allowed to plug in anything. So the domain of each function for f of x, remember, is negative 4x plus 3. I can plug in anything I want, so this would be all real numbers. G of x, there's no dividing by a variable, so in that one, I can do any real number I want for that. It could be decimals, fractions, all of that stuff. So this is, again, all real numbers. And then h of x, yet again, it is just a linear equation. It doesn't even have any exponents. There's no division of a variable, so that is also all real numbers. Therefore, the domains of all the new functions will be all real numbers, except for when I'm dividing. So the only one is D, where I have F divided by H. So this is all real numbers. Except for, what did I say, D? Which is F over H, F divided by H. Why? Because we divide by the divide by 0. So anywhere that H is 0, okay, so basically we're saying, since we can't divide by 0, any number where H of X is 0, so any number that causes that to equal 0 isn't a number we can use, so it's a number that's not in our domain. What we would do is we say that this is find the restrictions on the domain algebraically. If we have graphing calculators, we can graph it, but we're not going to look at that right now, but we would look at the charts from our graphing calculators. But we're going to do this just the alphabetically, ignoring the graphing part. So where we're doing it is we're going to say, where does H of X equals 0? So we are going to be solving. So we're going to do, remember that's y. So y equals 0. So we're going to do y equals 3x minus 1. We're going to put in the 0 for y. So 0 equals 3x minus 1. Add 1. You have 1 equals 3x. Divide by 3. Divide by 3. So x equals 1/3 is not in the domain. H of x to equal 0. So this is excluded. From the domain. All right, now, when we're talking compositions, that means that we're plugging in a function into another function. So the first thing that we have is different notation. So this is f. This symbol means of g of x. So this dot, this is the composition notation. This just means of. So the first thing that I like to do is I rewrite my equations. I do keep everything in order when we're looking at it, and we substitute stuff in. So we're going to look from that. Okay, so basically what we're doing is we're kind of thinking, we're unpacking things. So x is going to go into the g of x first. And then the g of x, that answer that you get, or that evaluation, will go into the f of x. And then that gets you into your f of g of x. So we're going to be plugging all of that in when we're looking at those type of things. So we can probably make it a little bit clearer. The last step is just that f of g of x when we're going through that. So just remember there's that of x along with this stuff. So sometimes we get a little bit lazy. So we could write it either with f of g, and then we could have the x is assumed to be there. If they just have the f of g, it's the same thing. So the first thing you're going to do, that I do, is rewrite this. So Nothing changes order, but I want to see the parentheses. G of x. All right, sometimes we get to plug numbers in first, but in this case, we're talking just x's because they didn't give us a number to plug in. So we're going to replace first that g of x. So this is going to become, we can work down or we can work across. So I'm going to leave that as this equals the f. Now, instead of the g of x, I'm going to replace it with the right side of it. So that's going to be f of 5x squared plus 7x minus 2. All right, so all of this is going to go in for the x in the other ones. So sometimes different colors will help. I am going to rewrite using pink. So f tells me I'm going to have that -4. And now I'm going to replace that x with this parentheses. So this is 5x squared plus 7x minus 2, close your parentheses, and then I have the rest of that f function. So plus, oops, no, it didn't change color. Let's change my color. Back to the equation is plus 3. So I took the f function and I'm just keeping all of the f stuff the same, replacing the x with that g of x equation or function, the right side of it. And then I'm going to simplify this because remember, functions we can't solve, but we can simplify. So I'm going to distribute this -4 to everything over there. So I have -20 x squared. -4 times 7x is plus 28x. And -4 times -2 is positive 8. And then I still have that plus 3. So solving all of the stuff, simplifying things as much as a problem, I have f of g of x equals a -20x squared plus 28x plus 11. So we're just plugging in one function into the other, replacing all the x's with that. It looks a little bit messier than it is. It is doable. Some things are easier than others. So we can plug a function into itself. So I'm going to leave that f of x for you to do. So we're going to do the g of h of x for you because it's a little bit more work. We'll have to do some distributing and stuff. So remember, this is of x. So this is the same thing as g h x. We're replacing that h of x with the 3x minus 1. So this is the same thing as g. And then I'm going to replace the 3x minus 1 because that is worth the same thing as h of x. I lost a parenthesis here. All right, so this tells me I'm going to my g function. I'm going to replace all my x's with this pink. So this is going to equal, starting with the 5, and then I see my x, so I'm going to replace it. Make sure I have that. 3x minus 1. I still have the squared, and then a plus 7. I see an x. I am replacing it with 3x minus 1. And then I have a minus 2. All right, so there's a lot more work to do. Remember, we only work on the right side simplifying it. The left side is what we're actually solving, or what we're trying to get, and it's just telling us the rules that we're going to be doing. Now, when you have a binomial, so 2 terms squared, I highly recommend writing it twice. So this is going to be 5 times 3x minus 1. 3x minus 1, because you are going to have to either FOIL it out or use your box area method to simplify that. We will put that down in our work in a minute. So plus, I can distribute right now with this. This term I can simplify, so I'm going to distribute my 7 to this. So this is 21x minus 7 minus 2. So now when I distribute, I have I'm going to do here. I'm going to put my terms out, but I'm also going to combine like so. 5. Combining like terms, I'm going to have, shortcutting it, actually I'll just rewrite what I have. So this is 9x squared, sorry. Foiling it out, please make sure that you've written it out and you can get, with your combining like terms, the 9x squared minus 6x plus 1 should be what you get when you FOIL it all out and distribute it. And then I have plus 21x minus 9. Distribute what I have, that 5, to everything in there. So I have 45x squared minus 30x plus 5 plus 21x minus 9. Combining like terms, you should get a final answer of g of h of x equals 45x squared minus 9x, because I'm doing these two together, minus 4. Okay, so we'll leave the I for you, and the J is kind of a bonus thing of seeing how you can do it. I will put the answer in with that. When we are plugging in a number, you have options. So you can plug in the 2 first, the G function, or you can plug the G of x into h of x. Then at the end, you can replace the 2. So we're going to show it both ways. I'm going to recopy what my G and my H's are. So we have, I'll do it here, h of x was the 3x minus 1, and g of x equals that 5x squared minus, plus 7x minus 2. Yep. All right, so if we do it the first way, we're plugging in the 2 to the g of x. So that is telling me that I am going to be doing h g of 2. So first step is g of 2, which equals 5. And I'm putting a 2 squared plus 7 times 2 minus 2 equals 5. Order of operations, do the squared. So this is 5 times 4 plus 14 minus 2, which is 20 plus 14 minus 2, which is 34 minus 2, which is just going to be 32, which is not the funnest of numbers, but it's okay. 32. So this really becomes, if I'm going down here, since g of 2 is 32, this is really just asking me to do h of 32, which equals 3 times 32 minus 1. 3 times 32 is 3 times 30 plus 3 times 2, which is 90 plus 6, so 96 minus 1 is 95. All right, so plugging in the 2 first, I'm working with numbers. It is your option if you want to do that. If you want to plug the g of x in first and to the h of x, that will look like, let's do that in green, h of g of x first. I'm going to put that my 2 here while I'm thinking about it. So what I'm doing first is going to be h of g of x, which is h of 5x squared plus 7x minus 2, which is just 3 times 5x squared plus 7x minus 2 minus 1 from my equation. And that gives me 15x squared plus 21x minus 6 minus 1. So that's 15x squared minus 21x minus 7. All right, so that is h of x. So now I'm taking this and I'm plugging a 2 in. So this becomes h g of 2 equals 15. I'm going to do that in, I'll change my colors. I want this to be this 2. So 15 times 2 squared minus 21 times 2 minus 7. So this is 15 times 4 minus 42 minus 7 is 60 minus, these two are both negative, so minus 49 is definitely has a problem. So I have an error somewhere, so we're going to look for where a mistake is, and I will come back once I find it. Okay, so easy question of where I found my mistake is looking at the problem here. I have a plus 21 and I somehow changed it to a minus 21, which causes everything else to change, just the sign. So this is a plus. This is a plus 42, which means I can't do that minus 49. It would be 60 plus 42, which is minus 9, which gives me, running out of room, 102 minus 7, which is 95. So watch your signs. We should get the same answer either way. I find that it is easier generally to plug in the number first and then deal with the expression. However, both ways work. So we're going to leave the last two for you to practice with that. And then there is some more practice sheets. I probably wouldn't, it's definitely not homework. It's just an example sheet for you guys. But that is some notes for compositions and some review of functions. So double check your answers once you've practiced them. And hopefully let us know if you have questions.